Hey, Pre-Cal 11, here we go, section 3.5. We are now solving rational equations. So we're taking everything we've learned, everything we've worked on up till now, and we are setting it equal to something else and solving. So to start, example one is a type of question we would have seen in grade 9, where you have three fractions and your unknown is in the numerator, and you need to get rid of the denominators in order to simplify your life. We get rid of the denominators by multiplying everything by the LCD. In this case, it's 6. And you can see that happens here. Multiply by 6, simplifies through, simplifies through, simplifies through. This is a grade 9 question. I'm sure you can all handle that. Where it gets a little bit more complicated is where we have now our unknowns in the denominator. But it's the same process. Get rid of the denominator. How do we get rid of the denominator? Multiply by the lowest common denominator. So, what is the lowest common denominator in example 2? It's x. Multiply everything by x. Simplifies, factors, you get your answer. So have a follow through there if that one's a little confusing, but let's move on to the more fun stuff. So example 3, we have unknowns in the denominator. Let's get rid of the denominator. Multiply everything by the denominator, by the lowest common denominator, which in this case is x minus 4. So 2x times x, whoops, sorry about that. 2x over x minus 4 times x minus 4 is equal to 8 over x minus 4 times x minus 4 plus 1 times x minus 4. Don't forget the 1. So, what happens? Cancel, 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 cancel. 2x equals 8 plus x minus 4. Let's rearrange. 2x equals x plus 4. And then subtract x, x equals 4. Done and done. But go to the very beginning. Domain restriction. X cannot equal 4. Yet x does equal 4. So what does that mean? No solution. And we denote that with this x equals 0 with a line through it, which means the empty set, which means there's no set of possible solutions. Okay? Let's do these ones. So, example 4, you can see we got a whole bunch of denominators. How do we get rid of them? Multiply by the lowest common denominator. Well, we have x minus 4, we have x minus 2, and if we factor x squared minus 6 plus 8, we get x minus 4 and x minus 2. So good news is, lowest common denominator is x minus 4 times x minus 2. Now rather than demonstrating me multiplying everything by that, what's going to cancel? The x minus 4 is going to cancel with that one, and you're going to be left with 1 times x minus 2. The x minus 2 is going to cancel with that one, and you're going to be left with minus 1 times x minus 4. And then this whole x minus 4, x minus 2 is going to cancel with that on the bottom. So equals 2x. That's the quick way. So now we have x minus 2, don't forget that, minus x plus 4 equals 2x. So we have 2 equals 2x. Divide both sides by 2. X equals 1. What's your domain restriction? X cannot equal 4. X cannot equal 2. So we're good. Now, it's not always going to work out as beautifully as that, but quite often it does. Example 5. x minus 5, x plus 1, factor this thing, we get x minus 5, x plus 1. So exactly the same as the last question. Multiply everything by x minus 5, x minus 1. So on the first one, the x minus 5 cancels with the x minus 5, and it's x times x plus 1. On the second one, the x plus 1 cancels with the x plus 1, and it's minus 3 times x minus 5, and then equals 30, because the x minus 5, x plus 1 cancels with the x squared minus 4x minus 5, because it is x minus 5 times x plus 1. Water bomb. We get x squared plus x minus 3x plus 15 equals 30. We always want to set these equal to 0, so subtract 30 from both sides and simplify the rest. And we get x squared minus 2x minus 15. And do we have two numbers that multiply to negative 15 and add to negative 2? X minus 5, x plus 3. So that means x equals negative 3, x equals 5. But what were the restrictions at the beginning? X cannot equal 5 and x cannot equal negative 1. So we reject that answer. It's not allowed. And we just say x equals negative 3. So far, so good. Let's look at example 6. Now I'm going to scroll up, just give myself a little bit more space. This is a scenario where the lowest common denominator is just the product of those two things. So I'll show this one in the detail that I didn't show. If you multiply the top by the lowest common denominator, right, this is what we've been intuitively doing. Cancel. So you only multiply the top by what's missing. So 4 times x plus 3 is equal to 2 times 2x minus 1. Side note, this is where people come up with the cross multiply analogy, which drives me insane because a lot of people don't know what they're doing. The reason why they cross multiply is because to get rid of the denominator, you've multiplied it on the left and it ends up being multiplied only on the right. And same here. But don't. Do it properly. Okay? So simplify. Water bomb. Water bomb. And we get 4x plus 12 equals 4x minus 2. Bit of an issue. If we subtract 4x from both sides, we get 12 equals negative 2, which is not true, which is never true. So what that means is this original statement was never equal to begin with. It's not possible. All right, so this is another scenario where there is no solution. And I think this is our last one. So I'll let you look at example 7 on your own. This is just an example similar to the last one, but instead of finishing with 12 equals negative 2, we finish with 0 equals 0. What that means is it doesn't matter what x is. This thing at the beginning was already balanced. Doesn't matter what x is, it's always balanced. The x is unnecessary. It's redundant. So when you end up with this, there are infinite solutions, except for your domain restrictions. And you'll see we have a domain restriction of x equals 0 and x equals 7. All right? So now let's just look at example 8. This is one where we're not solving for a number, but we want to isolate a. We don't want to isolate a in the denominator, so let's get it out of the denominator, but let's just get rid of all the denominators. How do we do that? We multiply by the LCM or LCD, which in this case is A, B, C. So the beauty is we've got 1s on the top, so multiply everything by 1. But what cancels, right? If you have ABC over A plus ABC over B equals ABC over C, some things are going to cancel. A, B, B, C, C. What are we left with? We're left with BC plus AC equals AB. Okay, now, where we go from here depends on what we're trying to achieve. And what we're trying to achieve is solve for A. So we need to isolate A. So you need to get A together. I'm going to subtract AC and subtract AC. So now I have BC equals AB minus AC. The reason I did that is because I can factor out an A, reverse water bomb. So BC equals A times B minus C. Now all I have to do is divide by B minus C on both sides. So A equals BC over B minus C. Done. I'm going to leave the practice questions for you this time through. Work through as many as you like. Answer keys in the back. Now, I'll stop here. It says check your solutions. You can just do that for a couple. Reason why I want you to check your solutions, and I don't think I gave you any in this scenario, but sometimes what you'll see in section 4 is you can have redundant solutions, or what we call extraneous solutions. So I asked you to check your solutions to make sure that they all work. They should all work, but double check anyways. So say, just for instance, how do you do that? Well, you know what? Why don't I just do this question? Common denominator is 9x. So we're going to multiply the first one by 3. So I'm going to have 15 over, or sorry, I'll just multiply everything by 9x. So the 9x cancels with the 3x, and I end up with 15. If I multiply the second one by 9x, the 9's cancel, end up with 15 minus x. Multiply the 4 by 9x, the x's cancel, I end up with equals 36. Now I get 15 minus 36 equals x, so x equals, what is that, negative 21. So after you get your solution, plug it in. 5 over 3 times negative 21 minus 1 over 9 equals 4 over negative 21. So you get 5 over negative 63 minus 1 over 9 should equal negative 4 over 21. Well, multiply this by 7 and 7, and you get 5 minus, oh sorry, this is a negative up here, just to make it more realistic. So negative 5 minus 7 over 63 should equal negative 4 over 21. And here you have negative 12 over 63 should equal negative 4 over 21. Divide those both by 3 and you get negative 4 over 21 equals negative 4 over 21. You could also just plug it into your calculator and make sure the two sides are the same. But it's just a good habit to practice to make sure that your solutions are both allowed, or if you get 1 or 2 solutions. But I'm almost certain in most of these cases your answers should check out. Okay, good luck with this one, and we'll be in touch. Have a good rest of the day and probably week.